Welcome to springlib.
This is the answer to Chapter 12, problem number 21 from the Smith Organic Chemistry textbook. And this problem gives us three molecules with multiple alkenes in them, multiple double bonds, and asks us to treat each of them with ozone followed by dimethyl sulfide, and to predict the products. And so this is going to be just like other ozonalysis problems that we've seen in this chapter. The only difference is that we have more double bonds in each of these molecules. But nothing else really changes. We're still going to solve these by just cutting across the double bonds and replacing them with carbonyls. I would point out, if you haven't seen this yet in my answers, you may notice that I use DMS as the abbreviation for dimethyl sulfide rather than drawing CH3SCH3. They mean the exact same thing. In my experience, DMS is a pretty common an abbreviation that you'll see pretty commonly in papers and stuff. So that's the one that I use. So that's all that the DMS means. It's the same as CH3SCH3. Okay, so to solve each of these, I would again recommend just drawing a big red line through each of these alkenes. And then drawing, what's to either side of these red lines, and just replacing the double bonds with carbonyls. And if it helps, you can keep the orientations the same so that you can see, exactly which pieces are which, so to speak. So here, it's going to look like this. And so each of these carbons that previously was part of a double bond is going to have a carbonyl coming from it instead. So let me redraw this a little bit. Okay, so maybe that's better. Okay, and so the other piece is going to be like this. So the other piece is 2 carbons long. Each of those pieces is now an aldehyde. So like this. Okay, and there we go. So that's the answer to part A. And that's the other two are going to follow the same type of pattern. So I will go ahead. I'll put the answer to B over here so that there's more space, so that we don't have to kind of crowd it in there. And again, I would recommend doing, the same thing, keeping the orientation the same, if that helps you, so that you can see like where each of these pieces fits together. So there's a carbonyl here. There's going to be a carbonyl here now. And then the other piece. The other piece is the other 3 carbons of the ring. So that's going to look like this. 1, 2, 3. And then we'll put our carbonyls here as well. Okay, and we can put the hydrogens in on these aldehydes. I know it's sometimes weird to look at aldehydes without the hydrogens on there, but that's really it for this problem. And so you could go ahead and redraw these and make them better looking if that helps you. I just drew them this way so that it's easy to see how they fit together in the ring. But if you really feel like you need to redraw these, you could redraw them like this. So here's our first piece, and then here's our second piece. So that's the answer to B, just redrawn. We could redraw A the same way. I don't really think it's necessary. So then looking at C, here we're cleaving one double bond that's in the ring and one that is exterior to the ring. So the part that's exterior to the ring, this part, we're going to get just one carbon out of. So we're going to get an equivalent of formaldehyde, which there it is. And then we'll also get this, Okay, and so there we go. And again, if you wanted to, you could redraw the part that came from the ring more linearly. It might be nicer to look at, but I like drawing them this way because it's easy to see where they came from and how these would fit back together into the alkenes that we just cleaved. And so I think that that's the way to approach this problem. Just start by drawing a big line through each of your double bonds, and then just drawing the pieces to each side of that line and making sure to replace the double bonds with carbonyls instead. And that's the answer to chapter 12, problem number 20.